Right, good morning. This is my second run through of this, as the first one failed to record, so I'm going to be keeping my eye on the little recording symbol. I hope this one works better than before. I'm going to run through the questions for the maths today. I'm going to do them quite quickly, and then what I'll do is I'll put the timestamps over each question on the video so you can have a look if you get stuck with any of them. Question 1 talks about the angles in a triangle being 70 degrees and 40 degrees. Jack here, our friend, has said that the triangle is equilateral. An equilateral is actually saying the same thing as it is regular. Okay, from our work on shape, we know that a regular means that all the internal angles, all the sides are the same. These internal angles here are not the same, so it's not a regular shape. The other thing that you can note about here is the other fact is that for equilateral triangles, all of the angles need to be 60 degrees, and if they're not, it's not equilateral. Okay. This one jumps over 2 pages, so let me just jump into that here. Okay, so we have here a diagram with a pentagon at the bottom. We've got angle A, we've got a couple of 150 degree angles. We've also got in here on 90 degrees at the bottom. The question asks whether it's a regular pentagon, circle yes or no. Again here, whether it's regular or not is going to come down to the lengths as a side, which are all the same. But then also it has to be the same as the internal angles, and they are not the same. So it's not a regular shape. It says here for us as well to work out the size of angle A. So if we have a think about that, what I can do here to help me out with this is actually kind of split this up a little bit. So if I draw a line across here, you'll notice that we've got different shapes here. We've got a rectangle at the bottom, we've got a triangle on the top. Now, I've got my 150 degrees is my whole angle, but we know that actually this angle here is going to be 90. Now, to work out this bit here, this top angle, that's just going to simply be 150 subtract 90, which is going to give us an answer there of 60 degrees. Now, thinking back to the first question, we know that, well, that angle is going to have to be the same, but also we learned there that an equilateral triangle has internal angles of 60 degrees. So if one of them is 60 and the other one is 60, the third has to be 60 because internal angles in a triangle have to add up to 180 degrees. Let's have a look at question 3. Is this on one page? Yes, it is. It appears to still be recording, which is good. Don't stop. Okay, so diagonals of this quadrilateral cross. That's right, okay, right angles. Let's have a look at where these diagonals are. We have one here, we have one here. A diagonal is simply a line drawn from each corner to the opposite corner. Opposite corners, line drawn across, that's our diagonal. They cross at right angles, which means that every one here is going to be a right angle. We also know the name for that is these are perpendicular. Lines. Okay. So we need to tick all the quadrilaterals that have diagonals which cross at right angles. 2 things to bear in mind here. 1, in the question it says all. 2, this is worth 2 marks. You're not getting 2 marks for ticking one shape, are you? So have a think about this carefully. In this one, what you need to do is you need to use a ruler. You need to draw all of the diagonals on before you start. Now you've done that, it makes your job easier. You can look at the first one that we've got here, and you see that actually those diagonals there, that's going to make a right angle. So this shape needs to have a tick. If I look at my diagonals here, I can see that those are not right angles. I can see that the top and bottom angles here and here, they're going to be the same, but those are going to be acute. I can see that the side angles here, these are going to be the same, but those are going to be obtuse. So that doesn't need a tick. This shape here at the bottom, being a square, means that all of the lengths are the same, which means that if I draw my diagonals in as I have, they're going to cross at right angles. Okay? If you turn your head round, if you twist your screen, twist your page, you'll see that. So this one here, again, is another one that needs a tick. If I look at my angles here, again, a bit like the one above it, I can see that I'm going to have 2 acute, 2 obtuse. So that one gets no tick. Question number 4. We have a shape and a grid. Okay, so looking at this, I can tell you, let's look at some facts of it first. It's a quadrilateral, it has 4 sides. I can spot an acute angle, I can spot 2 obtuse angles. So I'm going to put an A, I'm going to put an O and an O. And this one here, because it goes dot to dot to dot on isometric paper, that's actually going to be a 90-degree angle at the top there. Okay, so thinking about that, let's now look at our statements. The shape is quadrilateral, we've already answered that. The shape has 2 lines of symmetry. Okay, well, a line of symmetry is somewhere where I can draw a line down the shape and both sides are a reflection of itself. That's one. But this one here is not. That's not a line of symmetry. So this shape here only has 1 line of symmetry. The shape is a parallelogram. To be parallel, it means that the sides need, to be a parallelogram, it means the sides need to be parallel. And if actually if I extend these lines out here, we know the definition of a parallel line are lines that always stay the same distance apart. You can see here, they're getting closer and closer and closer together, and eventually they're going to touch. So those lines are not parallel, so it's not a parallelogram. The shape is a right angle. Well, we said at the beginning, if I clear this off a little bit, we said at the beginning that we thought this up here was a right angle. So, in order to check that, let's bring in our friend Mr. Protractor, pop that in there. Lovely. 90 degrees, right angle, tick for you. Okay, let's jump into question number 5. ABCD is a rectangle. What are the values of the missing angles? Well, it's a rectangle, which means that all the internal angles are going to be 90 degrees, which means that x here is 90. Despite the fact it's been drawn with a curved angle, it's going to be 90 because it is a rectangle. C, we need to know something about angles around a point. So if I have 2 lines here, if I opened up the angle in it, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Angles around a point, 360 degrees. Okay. So, if I pop this in here, that then looks like our angle C here. But I don't want C, I want the distance around the outside. Okay, but actually if we know here that C is 90, and we know the whole way around, 90 degrees, let's be proper about this, we know the whole way around is 360 degrees, that means that what we're left with for angle Y is purely going to be 360 subtract 90, which is going to give us an angle of 270 degrees. Okay, question 6. Jack says my rhombus is a regular quadrilateral. Well, Jack, let's have a think about what you're saying. You're correct. It is a quadrilateral. There are 4 sides. Regular, not so sure about, sunshine. If I look at my angles here, obtuse, obtuse, acute, acute. I don't need to measure them to know that they're not going to be the same, and if it's regular, all internal angles must be the same. And because they're not, he is wrong. Unlucky Jack. Question 7 jumps over 2 pages, so let's have a look at this. Okay, Ben's got 2 rectangles. Congratulations, Ben, you must be very happy. We have rectangle A and rectangle B. Yes, rectangle B. This is rectangle B. What is the special name of rectangle B? Well, if these sides are the same length, That means that all the sides are the same length. A quadrilateral, which is a four-sided shape with all sides the same length, is going to be called a square. Okay, a square is a special type of rectangle. Ben then takes his rectangle B and he pops it, takes it, and he goes, drops it on top of A. And we want to know what the length of this line is. That calculation is as simple and as straightforward as 12 subtract 5, which I'm pretty sure we're all quite good at. Okay, let's have a look at question number 8. Question number 8 is down here. Before I look at these on the right hand side, I promise you I'm not looking at them. Promise I'm not looking at them. I'm going to write down what I know about this. This shape is a quadrilateral. It's got 4 sides, 1, 2, 3, 4, 1, 2, 3, 4. I know that angle A is going to be 90 degrees, it's going to be a right angle. I know that B is acute. I know that C is obtuse. And I know that D is going to be 90 degrees again. Okay, and that's despite the fact that they're curved, because it goes corner here to corner here via this corner. It means that that has to be 90 degrees. Corner here via this one. It goes across the corners. It goes across the corners, the diagonals of the squares. That is always going to make a 90-degree angle. Okay. Now I'm going to look at my statements. I promise you I haven't looked at them. So angle C is an obtuse angle. Well, we've already talked about that. That's down here. Yes. Angle D is an acute angle. No, it's 90 degrees. AD is parallel to BC. So let's have a look at that. Here is AD. Whenever it says, I'm just covering in script. Let me get rid of this. Whenever it says something is parallel, we need to draw where those lines are. And the best way to do that is you draw the lines between the points. So line AD is this line here. Okay? And then line BC is this line here. And you can look at those and you can tell me straight away that those are not parallel lines. Okay? And then AB is perpendicular to AD. If I grab this line here and I pop it up here, this is line AB, this is line AD here. Now, perpendicular we talked about earlier. Perpendicular means that the lines meet or the lines cross at 90 degrees. Okay? And that's not a very good one, is it? Let me just move that down. There we go. So they meet or they cross at 90 degrees. Now, if that's the case for these, okay, if that's the case for these, then what we will have is we will have perpendicular lines. Okay, so if AB is perpendicular to AD, they're going to meet, they're going to make 90 degrees. We know that because I've already said that A is a 90-degree angle. Okay? Okay, question 9 here is just on a single page. So let's jump back into that here. Right at the bottom, there we go. So an isosceles triangle is a perimeter of 12 centimetres squared. One of its sides is 5 centimetres. What could the length of the other two be? So we're going to have some isosceles triangles. Okay? What we know about them is these lines are going to be the same, and then the line at the bottom is going to be different. So let's start with the line at the bottom being 5 centimetres. We know that our perimeter can only be 12, so I'm going to pop that there. If I do 12 take away 5, that's going to only leave me with 7 centimetres here for my perimeter, which I'm going to have to share between these two sides. So if one side is 5 at the bottom, that means that the other two are going to have to be 7 divided by 2. They're going to have to be 3.5 each. 3.5 at 3.5 is 7. 7 add 5 gives me my perimeter of 12. Okay, so if I had 5, 3.5, 3.5, it's going to give me 12. Now if we think about this the other way, let's make this side 5 centimetres this time. Well, if that's the case, if that's 5, that means that that must be 5 as well. So without really thinking or doing anything else, I know that one of my sides is going to be 5. 5 add 5 is 10, which means up by 12, centimetres for my perimeter, I've already used 10, which means I only have 2 left, and that 2 must be my bottom bit there, which is going to be my line there. So for my second isosceles triangle, I have 5 centimetres for one side, 5 centimetres for that other, because that was given to us, and 2 centimetres to the bottom. 5 add 5 add 2 is 12. Let's have a look at question number 10. These diagrams show the diagonals of 3 quadrilaterals. Right, the names of the quadrilaterals in the boxes. So what you need to do is you need to visualise this, you need to spot this, you need to try and pop these in. So let's go for a bit of a fancy dotty pink line. So I'm just going to pop them in like that. So it's a bit like a game of dot to dot, really. That'll tell you the name of our shape, rectangle. This one, dot to dot. We've seen this one before, haven't we? That's the kite. And then here. What does that look like to you? That's going to be our square. Question 11, final one. A shaded isosceles triangle is drawn inside a rectangle. We need to calculate the size of angle A. Now, things that we need to know. We need to know that here, because it goes from the corner to the corner, that this angle in here is going to be the same as that. Okay? Because it's the same length sides here and here, because it is an isosceles triangle. That means that this angle here is going to be this angle here, which is going to be 38. Okay? So at the moment I've got 38 degrees. I've got another 38 degree angle. And the final thing that I need to spot here, and this is all about spotting things in our maths, the final thing that I need to spot here is that actually my line along the bottom there, or anything on a straight line, is 180 degrees. So that must mean that my whole, let's see if I can do this one, that my whole angle here is going to be 180 degrees because it's on a straight line. Okay? Now if I've got 38 and 38, that means that A is whatever is left once I've taken 38 and 38 away from 180. So if I do that then, well, let's do that. So 38 and 38 is very similar to doing 40 at 40, which is obviously 80, subtract 4, it's going to give us 76. Then all I need to do is 180 subtract 76, and that will give me my answer for A. I hope that's been useful. Let me know. Cheers.